Lesson 3.1, we're going to be looking at solving systems of equations, and we're going to solve them graphically. A system of equations is two or more equations in which you want to find the solution or solutions that make both or all equations true. For right now, we're going to be dealing with two equations. The solution, so when you have a system of equations, the solution of that system are the points that make both equations true simultaneously. Right now we're going to look at graphing, which is a nice visual way to look at it, and we'll even talk about that as we move on to the other methods of substitution and elimination. So first I'm going to show you just the different possibilities we have when solving systems of equations, so especially linear equations. So first of all, and the one that we'll see most often, is you might have this line, that's one of your equations, and then another line, oops, it's not a very good line. And the solution is where those two things intersect, because this point is part of this line, and it's also part of this terrible looking line right here. The next possibility is to have one line and then to have another line that does not intersect it, and so therefore they would be parallel. So this one has no solutions. And then the last possibility is to have a line, and we'll see if I can do this correctly. Here's one line. So let's say we graphed one of our lines, and then we went ahead and graphed the other line, and it turns out that those graphs are actually the same line. And so that's the other possibility. And so let's go back. We have a few names here and a few things we can think about. This one here, this has one solution. So when you have two lines, you could have one solution. And when you have one solution, or later on we'll look at other types of systems, or if you have a countable number of solutions, if it's 2 or 4 or 7, that is called consistent. So it's consistent because it has a solution, and then it is called independent, because it's consistent because it at least has one solution, and independent because it has a countable number of solutions. Maybe we should talk about this one. This has infinite solutions. The solution to this is actually the line itself, because we have all the points that intersect there. And this is called consistent because there is a solution. There's at least one solution, consistent. And we call this dependent because there's an infinite amount of solutions. And then the last one, there's no solution because they never intersect. There's no point on the graph that makes both of those lines true, or that lies on both of those lines. And this one is called inconsistent. And since it's inconsistent, we don't even have to think about independent or dependent, so inconsistent. Sorry about that. Inconsistent. So those are our three types of possibilities when talking about linear systems of equations. So let's look at a couple examples here. We have our first one here, solve the system. So we'll solve this system, and then we'll come over here and solve this system. So in order to solve it graphically, we're just going to graph each of these. So it's helpful to have it in slope-intercept form. So we'll subtract x from both sides here, and we get y equals, and I'm going to put it in slope-intercept form, so I'll put the negative x first, plus 4. And I'll graph that. So y-intercept of 4, and then slope of -1, so down 1, right 1. And I'm just going to put several points along here so we can graph that well. points, and we can make a line through those points. Now let's go ahead and solve this other one for y, so we could subtract x from both sides. And we actually have negative y equals negative x plus 2, but it's negative y, so we're going to divide both sides by negative 1, which is really dividing each term by negative 1, so it changes our sign, so we get x minus 2, so we have a y-intercept of negative 2, and we have a slope of 1. And actually, when we use our slope up 1 and right 1, we see those two lines intersect right there at 3, 1. We can sketch in the line if you want to. I'll do this one in red, but we see the intersection is there, and so our solution is where the lines intersect, and our solution is 3, 1. So 3, 1, which means we could put that back in here. So x is 3, 3 plus y, which is 1, 3 plus 1 is 4, it works there, and then put 3 in for x here, 3 minus y, which is 1, 3 minus 1 is 2. So we see that that point works for both of these equations. Coming over this next one, again, we'll put it in slope-intercept form. So this one we can subtract 2x from both sides. So if we subtract 2x from both sides, we get y equals negative 2x plus 0. We don't need to put plus 0, but you can if you want. So we want to graph that. Well, our y-intercept, I'll write it in here, is 0. So it crosses at 0. The y-axis at 0, and then it has a slope of negative 2 over 1. So we go down to right 1, down to right 1, down to right 1, or we could go up to left 1 and continue that pattern, and we can sketch a line through there. And there's a line that passes through those points. And then moving on to the other equation, we could subtract 3x from both sides. And we get 2y equals negative 3x plus 2. We need to solve for y, so we could divide both sides by 2, which is really just dividing each term by 2. And so we get y equals negative 3 halves x plus 2 over 2, which is 1. Our y-intercept is 1. And we have a slope of negative 3 halves, so down 3. 1, 2, 3, and right 2. Puts this here. We could also go think of this slope as 3 over negative 2. So we could go up 3, 1, 2, 3, and left 2, and actually we see that's where the intersection is going to be. We'll go ahead and sketch this one in. They're going to look close, but I think we can get it in here. And they intersect there at negative 2, 4. We could put those back in. 2 times negative 2 is negative 4, plus 4 is 0. And we could put it in here. 3 times negative 2 is negative 6. Plus 2 times 4 is 8. Negative 6 plus 8 is 2. So these worked out both nicely. They intersected at a nice lattice point there. They were both integers. The disadvantage to solving systems by graphing is, I'll just do it on this graph here, but if our two lines intersected like that, we have a rough idea of where they intersect, but like what point is this? This is maybe 4.5 or 4.6 and 4.1 or 2 or 3. So that's a disadvantage. We can't always get a nice exact answer by looking at our graph. So that is solving systems by graphing. The next lesson we'll look at solving systems by and elimination and substitution.